Please follow along on your handout as we do this problem together. A man pulls on a 40-kilogram dog's leash with a force of 80 newtons. The dog slides backwards at a constant velocity. The leash is at a 20-degree angle with the horizontal. Number 1, draw a qualitative force diagram for the dog. Please pause the video and try number 1 by yourself. When you're done, press play to check your answer. A gravitational force pulls down on the dog. A normal force pushes up on the dog. A tension force pulls to the left at an angle of 20 degrees. A frictional force pulls to the right. Number 2, create a force table. Use a protractor, a ruler, and graph paper to A, determine the forces that act in the x direction and the y direction, B, determine the normal force, and C, determine the frictional force between the dog's paw and the ground. Let's begin by listing the forces that act on the dog. We have a gravitational force, a tension force, a normal force, and a frictional force. Let's start with what we know. We know that the dog has a mass of 40 kilograms. We can use this to calculate our gravitational force. The gravitational force pulls down on the dog, so it acts in the vertical or y direction. To calculate the gravitational force, we use mass times 9.8. 40 times 9.8 equals 392 newtons. Because gravity pulls down on the dog, this force is negative. Gravity only acts in the vertical direction, therefore our x component of the gravitational force is 0 newtons. Let's begin our diagram with our gravitational force. Let's use a scale of 1 centimeter equals 40 newtons. Our gravitational force is negative 392 newtons. Let's begin by setting up a conversion. Negative 392 newtons times 1 centimeter per 40 newtons equals 9.8 centimeters. Let's begin by drawing this gravitational force. The gravitational force acts in the downward direction. The force is negative 392 newtons, and I drew it at a scale of 9.8 centimeters. Now let's do our tension force. Our tension force is 80 newtons at an angle of 20 degrees. Let's begin by drawing our 20-degree angle. We know that our tension force is 80 newtons. Let's use a conversion factor of 1 centimeter per 40 newtons. Using this conversion factor, we see that we should draw our vector at a size of 2 centimeters. Let's go ahead and draw in our tension vector. This is our force of tension. As you can see, the tension force does not act in just the x or y direction. Our tension force has a vertical component and a horizontal component. Let's calculate these components. Let's begin with the horizontal component. Our horizontal component measures 1.9 centimeters. Using our conversion factor, that 40 newtons equals 1 centimeter, we obtain 76 newtons for the horizontal component of our tension vector. Because this acts in the negative direction, we are going to write that our horizontal component of tension is negative 76 newtons. our vertical component. When we measure our vertical component, we measure the component to be 0.7 centimeters. Using our conversion factor of 40 newtons per 1 centimeter, we obtain a vertical component of 28 newtons. The vertical component of the tension is 28 newtons. Because the dog slides backwards at a constant velocity, we know that our total force is 0 newtons. Our total force in both the horizontal and vertical direction is 0 newtons. In addition, we know that the vectors must end up where they start as we add them all together, because the total is 0 newtons. We know we have a vertical force, our normal force, and a horizontal force, our friction force. We know that these forces must end up at the starting point, so we can draw them in now, our frictional force and our normal force. We can now use this diagram to calculate both our normal force and our frictional force. Let's begin with our normal force. Our normal force measures 9.1 centimeters. Let's use our conversion factor. 40 newtons per 1 centimeter, we get 364 newtons. Because the normal force acts in the upward direction, this is positive. Our vertical component of our normal force is 364 newtons. Because our normal force only acts in the y direction, our horizontal component is 0 newtons. Now let's calculate our frictional force. Our frictional force measures 1.9 centimeters. Let's use our conversion factor. 1.9 centimeters times 40 newtons per 1 centimeter results in a frictional force of 76 newtons. Because the frictional force acts to the right, it's a positive value. Our horizontal component of our frictional force is 76 newtons. Because it acts only in the horizontal direction, our y component of our frictional force is 0 newtons. Now we can double check based on our table and make sure that our forces add up to 0 in both the horizontal and vertical direction. Let's do the horizontal direction first. 0 plus negative 76 plus 0 plus positive 76 gives 0 newtons. Our x or horizontal components look good. Let's check our vertical components. Negative 392 plus 28 plus 364 plus 0 gives us 0 newtons in the vertical or y direction. Let's return to the problem and make sure that we've answered the questions. A, determine the forces that act in the x and y direction. We've done that and listed those forces in our table. B, determine the normal force. Our normal force is 364 newtons, and that acts in the vertical direction. C, determine the frictional force between the dog's paws and the ground. Our frictional force is 76 newtons, and that acts in the horizontal direction. We have now completed this problem. Please review this video if you still have questions, and we will work on practice problems in class tomorrow.